Hi everyone. In this video, I'm going to run through a design use case. Now, the design use case I'm going to run through is a heating system design with radiators on the first and second floor, and I'm going to connect that via a open loop system to the underfloor heating downstairs. Now, I'm not going to run into any of the specifics on these. Other videos cover that a lot better than this would. The purpose of this is to just show how I would go about modeling this type of system as quickly as possible. Okay, so to get started, we are going to use this modeled heat loss design of this 3-story house. Now, I've got room by room heat loss values and a total building and floor heat loss. Now, based on my total building heat loss of over 5 kilowatts, I'm going to use a heat pump that's going to provide at least that kilowatt output. What I would recommend to anyone using h2x is to set up your own product library and to use a tag to identify it. So I'm going to use my equipment project here that I've identified using the equipment tag. Type that in there, and then that will be recognized whenever I click this button on my projects. Now, if I go onto that design or that project, I'm going to be met with a list of different equipment that I've pre-configured and set up on older projects. Now, we've got this split by floors, by manufacturer. So I've got some mid-year heat pumps here, and I'm just going to select a unit that will satisfy my needs. So I'm going to go for this 6 kilowatt R32, and I'm just going to copy and paste that into this design. You can see that if you zoom out slightly, it'll be highlighted in that blue hue color. Now, if we hop over to design and make sure that we're on heating and cooling and heating, we can drag that over to where that heat pump is going to be located on the plan, and we can rotate it using these design tools here. Place that there. I'm also going to go and select a cylinder. Any of these will do. Copy that and paste that on the plan. And again, drag it into place when we're on the heating system design mode. Once you've placed this cylinder, you just need to make sure that you add the kilowatt rating to the coil. Now, because I've used a 6 kilowatt heat pump, I'm going to add 6 kilowatts onto those preheat inlets, which will be used to size those pipes going to the inlets on the unit itself. Now, what I can do there is actually swing from right to left. So I can put the inlet on this side, because this is where I'm going to show my diverter valve and my lock shield valve. Okay, to draw directly from that cylinder, you'll notice, by the way, that this doesn't have the pre-connected pipes that it will do if you select it from the drop-down menu. It will come with nothing to it if you copy it from another project. So I'm just going to use the multi-pipe tool here to pick up my flow and return on the upstream side of the cylinder. And we're going to bring that out and then across like this. And then go to type in H to bring those pipes up to a pipe height of around 2.5 meters to represent them running through the ceiling across to my heat pump location. I'm then going to drop them outside the building there and run them past those connection points. Now, the reason I've run them past is because it's easier to connect to plant like this, essentially running past with your inverted commas connection pipes and then connecting up the individual pipe work afterwards. Now, because I'm a bit particular with this, I want my flow pipe to be on this side. I want my return pipe to be on the other side. And to do that, we can rotate it 180 degrees using these buttons here. And then we can switch it from right to left, and that'll swap the inlet and outlet locations. I can then use multi-pipe to pick up those 2 points. You'll know that we're only picking up those 2 points because those circles will only appear on those node ends. And we connect up the return and the flow like that. Right click and drag to delete, and you'll notice that all of those pipes have turned blue because we need to add the lock shield valve on the return. Now, it helps me usually to click onto the lock shield valve and to reduce its size because that'll make it a little bit smaller on the plan and just make it a little bit easier to coordinate pipe work after the fact. Okay, I'm going to do the underfloor heating first. So if we switch over to underfloor heating, we'll grab the manifold and we'll place it in this store cupboard up at the top. We'll then be able to click onto that manifold, go to and associate the connected rooms and set out the unheated areas, set out the loops as required. And as you can see on other system design help videos, we won't go through it in too much detail today because the purpose of this is just to show how I would model the system quickly. Now, to connect that to our heating system design, what we need to do is our heating flow system. So we go off the underfloor heating flow system and connect from here, bring those pipes at a higher level over to our manifold location. Now, luckily, the lock shield valve, the return pipe, is on the correct side and is lined up nicely with our incoming return pipe there. So I'm going to do a left click and hit escape and leave those pipes there for now to connect to later. Click onto this pipe, hit delete, and then I'm going to grab this lock shield valve, hold control, and drag it closer to my manifold. You'll notice the manifold has shrank to suit the size based on the number of outlet underfloor heating loops coming from it. You can then click away to make sure that we don't move the lock shield valve when we do this next motion. And we're going to do the same thing with that cap end. Hold control, drag it closer to the lock shield valve, and then click away. We'll then be able to grab our heating return pipe and connect that up like so. And we'll be able to run our flow pipe past this valve here. And we'll repeat the steps we took with the lock shield valve and the cap end, drag it a little bit closer, and then we can grab a feed pipe and connect that either from the feed pipe here and drop it down, or we can go from the valve and connect over to the feed like that. Right click and drag to disconnect that or delete it. Right click and drag to select it, and then you'll be able to delete it. Now, to connect this system between levels, what we need to do is use our risers here. So we'll put a riser there and one there. Able to use that to connect on level 1 beneath the floor. Now, because we can't have our pipes rising up past this doorway to level 2, what we're going to do is we're going to connect some pipework beneath the floor, and we're going to use multi-pipe to select both of those risers. And I did that incorrectly. We need to select multi-pipe, click on those, type in H before you do your second left click, type in -0.1 to put them at 100 mil below the floor, and bring them over to our cupboard off to the left. We'll then be able to rise up the back of that cupboard, and that will appear on level 2. Now, because we don't want these risers appearing on levels that they aren't actually on, we can click on that and set the top floor to be level 1. Now, they won't appear on level 2. We just have to refresh that by going back down to level 1 and then going up to level 2. In a similar fashion, we need to do that for these risers so that they don't appear on the ground floor. Set the bottom to be level 1. Okay, now we have some risers to connect to. If we want to do our radiator layout on this level, we can use multi-pipe and connect to these reticulation pipes and run them to the right and to the left from the hit and escape after we've run both of those initial lengths. To set up the radiators, click on the radiator tool there, where you'll be able to select a manufacturer type. It might be one that you've uploaded via the marketplace. You'll then be able to select a range and a height or length restraint. Now remember, h2x will size this radiator based on the flow temperature and return temperature from your connected heat source downstairs. If you don't have a connected heat source, it will be based on the flow temperature from the system settings. Now we'll do a left click here to place the radiator, and then additional left clicks will allow us to run the tails. Now to get these lined up nicely, I would do a left click prior to my connection point, hit escape, and just drag those with a left click and drag over to there and there. That'll keep it nice and straight. Now we'll do that across both of these levels really quickly. Now we've finished connecting up our radiators to get a sense check of where these pipes are running and what heights, whether we've set everything correctly. We can go to our 3D mode where we can view all of our levels by clicking on this button here in the top right, where that'll show all of our levels. If we just want to look at system design, you can go to the visibility controls and turn off the walls and the windows, and you'll just be left with the system design. The level that you choose will determine which PDF shows in the 3D view. So you can see there that we've got our heat pump coming up to a high level, going across to our cylinder cupboard, and then splitting off to our radiators on each of those respective levels. With this type of system, one very important step is add the diverter valve at hot water priority location. So that will be in our cylinder cupboard here. Now, looking at it, we need to make sure that this is it at least has one T connection. Currently, this is a three-way elbow and then another elbow on the bottom there. So what I would do is just check what this height is. Make that the same height on the outlet. Say bring that to 0.75. Might be a good idea to do that here as well. Or you could keep these pipes high, up at 2.5 meters. But we just need to make sure that there is one T piece for the diverter valve to attach to. Click on there, we'll place it, and that will make sure that the greater of the domestic hot water load and the downstream heating load, that's both the underfloor heating and the connected radiators upstairs, greater of either of those two will go onto those primary pipes to size the heat pump. Now, if we hit results, we'll get our pipe size and information, and you'll be able to go and assess any of your warnings, such as the underfloor heating temperature too high warning that's showing up there, and yeah, essentially look at your pump duties, look at your sizes, and yeah, get all of the different exports. And that's the drawing set, the heat load reports, design reports, etc. As always, if you found this video, feel free to leave a like rating and subscribe to the channel if you'd like to see more content like this. If you'd like to see a different use case, maybe a different type of system design, feel free to leave a comment below. Let me know what it is you'd like to see. For now, thank you very much for watching, and I'll see you later.